The charge is carried by the conductors, because of which we can tell that the electrostatic potential of that conductor increases. A capacitor is the system of two conductors which is separated by an insulator. So the maximum electric field that a dielectric medium withstands without breaking its property, that is insulating property, is said to be your dielectric strength. Hello everyone, I'm Rinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 4 of chapter 2, and chapter name is Electrostatic Potential and Capacitance. So here today we are dealing with capacitance part. So now, capacitance of the conductor. So you all know the conductors are the one which carries charges. So the charge is carried by the conductors, because of which we can tell that the electrostatic potential of that conductor increases. Okay, so potential is the ability to bring the charge from infinity to a point. So when this is a case, so the charges which is present in the conductor increases its potential. So now we can tell that the charges are represented in the form of Q, alphabetical term, that is capital letter Q. So Q is the charge which is directly proportional to the electric potential. Potential is given in terms of V and whose SI unit is said to be volt. So now the charges of the conductor is equal to, on removing the proportionality constant, we have got it as C into V. So C is said to be constant, a constant term, and this term is said to be a capacitance. It is called as capacitance. So what is capacitance? See, capacitance of a conductor is the ratio of the charge to the raise in its potential. So this is the formula of capacitance of a capacitor. So here we have, suppose this capacitor is said to be 1 farad. Why farad? Because capacitance SI unit is farad, or it can also be called as the charge SI unit is given as coulomb and potential's SI unit is given as volts. So it can be coulomb per volt. So coulomb per volt or coulomb V inverse. So either you can write like this or else you can just opt for this form. Okay. So when can you say capacitance is 1 farad? So how do you define 1 farad? The capacitance of the conductor is said to be 1 farad when 1 coulomb of charge is required to raise its potential to unity. Okay, so what is the capacitance of a conductor? Capacitance of a conductor is said to be ratio of the charges to raise in its potential. But when can you say the conductor is in 1 farad? The capacitance of the conductor is said to be 1 farad when 1 coulomb of charge is required to raise its potential to unity. Unity means it is 1. So that is the concept of 1 farad. So in this topic, I hope you are clear with what is meant by capacitance. How is the origin of the capacitance takes place? That is due to the charges which is directly proportional to the potential, and on removing the proportionality constant, you have got C, which is said to be capacitance. Having its formula, you just explain what is meant by capacitance as well as 1 farad. So this is the concept. Now, you also have SI units. Next is going on to capacitor. So what is meant by a capacitor? A capacitor is the system of two conductors which is separated by a insulator. A capacitor is the instrument which is used to store the charges. Okay, so capacitor is the instrument which stores the charges. And how is the setup of the capacitor? So the capacitor, which is the one which is made up of two conductors and which is separated by an insulator, and that insulator can be called as a dielectric medium which is present in between the places. So capacitor, visually we can see, how can we see that? That is two conductors, in between the dielectric medium is placed. So what is the function of the capacitor? Function of the capacitor is to store the charges which is present in that circuit when the source is on. So capacitor is said to be a passive component. What type of a component? There are two types of component, active component as well as passive components in your electronics. So the capacitor acts as a passive component. So what is meant by passive component? The component which does not require any external energy to operate other than the source. Such kind of a component is said to be a passive component. In that, capacitor is one of the form. So how exactly the functioning of the capacitor takes place? I hope you have seen such kind of an components in your electronic gadgets, or whenever the TVs or in any other electronic gadgets. So here you have got capacitor. So how exactly we depict the capacitor? That is in this form. This is one of the symbol wherein you just represent the capacitor, or else you have this. So arrow which crosses from one plate to the other plate, that resembles, that is a change in capacitance. So there is a change over there in the capacitor. So which is called, also known as a variable capacitor, and here you have got a fixed capacitor. So there are two types here, fixed as well as variable, one which varies, which are represented in the following diagrams. Okay, so here we have got a capacitor. So these two are the symbols like how to represent. So here we have a capacitor and the charges are flowing. So here it is positive charges on one conducting plate and the negative charges on other conducting plate, which is separated by certain distance, call it as D, and the inside part is filled with a dielectric medium, which is also called as insulating medium. So here there is a electric field which passes. So the electric field direction is given by positive to negative direction. And how does the potential act with regard to the electric field? That is, the potential is always opposite to the electric field. So if this is a field, this will be the potential which is acting. That is all about your basics concepts of capacitors. I hope you got to know the capacitance of a capacitor and how exactly the charges of the conductor behaves and how you have introduced the capacitance formula. Capacitance is equal to Q by V and its SI unit, as well as you got to know what exactly is the capacitor mean, because you have already seen this. Some of you don't know the names. You have seen these components. So this is a capacitor which you can see in each and every gadget. So here we have a capacitor, means it's a system of two conductors which is separated by insulating materials in between. So coming on to the next concept, it is dielectric strength. So what is meant by a dielectric strength? That means there is a capacitor over here which has got a separation, and that separation is nothing but a medium which is present there that can be called as insulating medium or else a dielectric. So what is meant by an insulating medium? That is the one through which the flow of charges doesn't take place. That is, the current doesn't exist there. Such kind of a medium is said to be insulating medium. So here there is a presence of insulating medium between two conductors. So what is a conductors? Conductors are the one which conducts electricity. That means there is a flow of charges in particular materials. So now when there is flow of charges over here, how does this dielectric or the insulating medium behave? It is just that it does not allow the leakage of any charges which is stored in the capacitor. Okay. So what is meant by dielectric strength then? That is the strength of that medium such that it does not allow any of the charges to pass through it. So let us just explain. It is the maximum electric field that a dielectric medium withstands. Dielectric medium, it withstands the maximum electric field without breaking down its insulating properties. So what kind of property does dielectric medium possess? That is the insulating property, which is important word here. So the maximum electric field that a dielectric medium withstands without breaking its property, that is insulating property, is said to be your dielectric strength. So that is all about your dielectric strength explanation. And now we have got parallel plate capacitor. So what is meant by a parallel plate capacitor? So you have parallel, you have got a parallel diagram over here, and this is a capacitor, parallel plate capacitor, which has got positive charges over here as well as negative charges at other end, and there is a insulating material which is present in between, and here there is a field which passes and it is separated. The plates, the parallel plates are separated at a distance called as D. So in case of this parallel plate capacitor, we have two conductors, call it as conductor A as well as the other conducting plate, that is B. There are two conductors, A conductor plate as well as B conductor plate. So A conductor plate consists of a positive charge and B conductor plate, there lies a negative charge. So each of the charges, that is each of the plates, have got the charges called as plus Q and minus Q. So each of the places consists of plus Q charge and minus Q charge, and its continuous charge distribution is, we are talking about the surface charge density, which is given by plus sigma and minus sigma. So we have these things. These are the experimental setup or the setup, initial setup. Okay. So now here we are talking about working. So how does it work? So when we talk about working, we just have the picture in our mind, that is there are two plates, plate A and plate B. Plate A has got positive charges and its surface charge density is plus sigma. Plate B has got negative charges and its surface charge density is minus sigma. So now when there is electric field induced on the capacitor through the battery which drives the charges throughout the circuit. So here we have got positive charge and other plate we have got negative charge. Due to the dielectric medium which is present between these two charges, that is, it is called as an insulating material. That means there is no flow of charges from one place to the other place. So when that is the case, the charges which is driven by the battery accumulates on the plates. That is, the positive charge moves towards the plate A and negative charge moves towards the negative side. So when this thing happens, the electric potential increases in the whole circuit. The potential increases there. Due to the increase in the field, the potential also increases. So now we have got that the potential increases and it becomes, that is the applied potential will become equal to the actual potential of the system. So the potential difference which is acting between the plates will later become equal to the applied potential difference. So now we have got charges plus Q and minus Q. So this is a working which I have told verbally enough. So now we have plus Q and minus Q are the charges on A and B. Then we have the charge density, positive charge density is equal to Q divided by A, and negative charge density is equal to minus Q divided by A. And we know that charges which is present on the surface of the conductor is given by E, that is electric field, is equal to sigma notation divided by epsilon naught into n vector, which is a unit vector, in order to balance the other side of the equation. So having this, we know that sigma, it is a positive component, so we will just apply this. So it is vector E is equal to, you have got Q divided by epsilon naught into A into n vector. We also know that the potential, that is, we know that the potential V is a result of the product of the electric field and distance between the two plates. So now consider this as equation 1 and take down this as V divided by D is equal to Q by epsilon naught into A. Just cross it over. So we have epsilon naught into A divided by D is equal to Q by V. So what is Q by V? As we have studied earlier, that is ratio of charges to the raise in its potential. That is nothing but the capacitance. So C is equal to epsilon naught into A divided by D is the capacitance which is mentioned over here. So parallel plate capacitor, that the capacitance of the capacitor is given as epsilon naught into A divided by D. Because of this equation, we know that the capacitance is directly proportional to area of cross section. Capacitance is directly proportional to the area and inversely proportional to the distance lying between the plates. And the capacitance depends upon the size of the capacitor, as well as it depends upon the dielectric medium surrounding the conductor, as well as conductor which is nearest to the capacitor. So it depends upon all these properties. In today's class, we have studied about the capacitance, how you represent the capacitor, and the 1 farad definition as well as capacitance definition, along with the parallel plate capacitor. Having the parallel plate capacitor, you have studied its working as well as the formula. C is equal to epsilon naught into A divided by D, because of which you got to know on what conditions, that is on what properties does your capacitance act, that is capacitance depend upon. So that is all for today. Let us all meet in our next class in last bit of the chapter 2, that is electrostatic potential and capacitance. Until then, have a good day. Thank you.